interested in machine learning. Machine learning? You just nodded your head. This is the project for you. In a lot of machine learning projects, you typically work with labeled data. But this is not your typical machine learning project. We work with unlabeled data, which is way more interesting. It's just more realistic and it's way more fun. Apart from that, here are 3 more reasons why you should join us here at PROCON IT.
PROCON IT is a modern and thriving company. Each and every of our 220 employees contributes to our unique culture and team spirit.
As a consulting company, we have access to the most interesting and relevant projects in not only one, but various business areas, be it finance, automotive, manufacturing, or the food process chain.
The project combines a high-impact predictive maintenance scenario with state-of-the-art cloud technology. At PROCON IT, we have consultants for many fields of expertise.
Not sold yet? Here's a bonus reason. Bonus reason!
This door is always open and I am always up for a round of billiard.
So far so good. But what is this project about?
Hi everyone. This project is about a remaining lifetime estimation in semiconductor scenarios. These semiconductors can be found in transistors and they again are part of power modules. These power modules run our modern world. They can be found in photovoltaic systems or wind turbines and even electric cars. So you want to make sure that all these systems run reliably and therefore you want to monitor the conditions of these transistors and semiconductors and make sure that you can maximize their lifetime. These transistors consist of different materials with different thermomechanical properties. Hence, they will behave differently, for example, when they expand or contract under the influence of temperature. This leads to thermomechanical fatigue or even an eventual failure, and you want to be able to monitor that, especially if an eventual failure would cause a critical damage to the system in operation.
What influences the lifetime of a transistor the most?
Extreme situations!
We're looking for anything but normal circumstances. We're hunting for anomalies. Are we? How are we going to learn anything from data we know nothing about? Welcome to the challenge that is predictive maintenance. It is very hard to do predictive maintenance without machine learning. How do I get from my unlabeled data to valuable information? How can I turn the unlabeled data into labeled data? In our case, labeled data means anomalies. So the real question is, where do we get those anomalies? Now I could slam the transistor with a hammer or set it on fire, but you can clearly see why this isn't the most intelligent solution. So instead, let's get creative and design our own anomalies.
You might want to ask, why are we using simulation data? There are a couple of reasons. First of all, with simulation data, we have full control over all data that we look at, and we can easily introduce artifacts. Usually, you would gather years and years of data in order to see even one example of such an artifact. The other reason is that we can cover all edge cases. Thirdly, we can even simulate environmental conditions from all over the world. In this way, you will visualize all the findings on a website, for example, where that a data analyst can then access and even get a trigger warning, and then they can even schedule a maintenance procedure.
Hey Chris, let's shoot some pool.
Gotta go. Bye bye.